Okay. So just a quick little recap of what we did at the end of last time. If I've got something like this, I've created a variable that contains a student. It's a box that has a student in it. And if I say b equals a student, whenever you see those equals, it copies over the contents of that variable. What is the contents of a student? Well, it's a student object, so it's going to copy over the contents. So if I do something like this, if I change one of the two, I only modify the one, right? Because it's a copy. I made a copy and I modified the copy. I left the original alone. But if I do something like this, I actually have two pointer variables pointing to one student. And if I change it, it changes it for both of them. Because really, it's only the one thing. There's only one student object, but two pointers getting you to it. This is more similar to what you're thinking like in Python. Because Python's, it's all pointers. This might throw you off if we go back to this example, because you're thinking, well, you know, in Python I never had to specify it was pointers. In Python it was just all pointers. Like, how come here it knew to make a copy? C++ is the weird one here. C++ is the one making the copy for you. A lot of the other languages are using just the pointers. And then, of course, there was this one, which I'm not going to do a lot of in this course. Here, really, there's actually only one student variable, but I've got two names for that exact same variable. That's what it is with the ampersand. And if I change the one, I change the both. So there's the three differences. The first one was I had two student objects and I made a copy. Another one was two pointers pointing at one. And now here I've got one variable that has like two different names. So it made a copy for us. In this example, C++ was really cool. It did us a big favor. It automatically made a copy of that object for us. It knew how to do that. But we got really lucky because C++ knew how to do this for us because it's a very simple object. It's a simple object where really the only contents of that object are just like little primitive type variables. There's strings, whatever. But like they're very simple. Very simple things. It's smart enough to know how to make the copies of those. But we're going to run into a bit of a problem as we go on. If we have more complex things, like if we have variables that are actually pointers, we're using dynamic memory, blah, 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 there's a lot of reasons this can get more complicated. And C++ won't know what you mean when you want to make a copy. It won't know by default. It knows how to do it like really with simple stuff, and it'll try to do it for you, but sometimes it's just not going to do the trick. But to be super safe, what we're going to do is we're going to write and define a very special thing, something called a copy constructor. It's a constructor that gets called when we're making a copy of something. So this is an example of a very special function, a very special constructor that gets called automatically when C++ knows it wants to make a copy of something. This is going to be like its header. I would add this like to my header, and it's got to be like this. We have to have the name of the class, constant, student, it's got to be the ampersand, obj. Obj is going to be like the reference to another student object that I'm making the copy of. And if I add it to my class file, it would look something like this. This is a very simple one. Very, very, very simple. All it's doing is just making a copy by assigning, like, okay, what's the one I want to make a copy from? Take its first name, I'll assign it to this new one's first name, name, and so on. I'm just copying over the contents. That's it. C++ is smart enough to do this for us, but it's good for us to write it ourselves. So we can be explicit, this is exactly how I want you to do it. There. So now, if I wrote something like A student equals B student, in the example where I had variables of students, it would call this constructor. It calls this. So quickly, I'm going to add this to my code. So let's go here. I'm going to go to my header. Another constructor. And I'm going to go take the code. Can't see me, but I'm taking the code. And we're going to go to our class, student, and we'll write it here. So now, if I ever make a copy, it'll know, like, this is how it does it. If I go back here, I'm going to go back to this code. Where did it go? My main, I'm going to get rid of this here. So this is just the example code we just saw. Right? It said B student equals A student. So I'm making a copy of A student. So if I call, on that line of code, line 9, it's going to call that copy constructor. In fact, we can always test this question. Is this function running? Here's how I'm going to test it. I'm going to go to where it's defined, and at the very beginning, here's what I'm going to do.
There's a space before
Huh? Oh yeah, good eye. Oh, and I think I need to include IO stream here. So now, the very first thing that's going to run inside the copy constructor is, in fact, let's make it more obvious. I am running from the copy constructor. If this code gets run, what's the very first thing that this method's doing, the constructor doing? Just printing something out. You might be thinking, well, this is a constructor. It's a special one. It sets everything up. Well, yes, but it's still just like a method, a function, the same. It's still going to execute all the code inside of it. And what's that first line of code say? Print something out. So if this gets called, this being the copy constructor, when I run this line of code, the very first thing we should see printed out by this program is I'm running from inside the copy constructor. Let's make sure I'm not crazy. Building it, it's doing its thing. Who here believes me? Who here? No way. Okay. Nope, gotta rebuild. Should work, if I'm not crazy. Let's have a look. Look at that. I'm running from the copy constructor. It ran. So it ran the code. It ran that copy constructor for us. C++ is smart enough. Oh, you're doing an assignment? That means I need to make a copy of this type of object. What's that type of object? Oh, it's student. I'm going to go check to see if there's a student object copy constructor. There is. I'm going to use that code. It connected all those dots for you. Pretty handy stuff. All right, back to the slides. Copy constructor, great. So there we go. Oh yeah, if you're wondering about this, remember it's a pointer to itself. In this particular example, I didn't actually need this, but I like it because then it makes it obvious, wait, whose first name is it? Well, it's this one versus the other ones. Copy constructor test, I literally just did it. Oh yeah, I like this. I'm running, I just showed you that. Do note that in the first case, it called the copy constructor automatically with the equals. But if I want to make a copy of an object from dynamic memory, like using that new, I would do it like this way. And of course, I need the star in front of a student. Why? Because it's a pointer and I don't want to make a copy, like I can't make a student object out of a pointer to a student. It needs to be an actual student, so the star dereference, get the actual thing I want to make a copy of. It all works out. Cool? Cool. For better or worse, copy constructor, the magic code. This is how you use it. So copy constructor, if you don't believe me, test it. Yeah, it'll work. Summary, okay, so far what have we seen? Headers, it's where we say what it's going to do, but not how we do it. There's 1,000 asterisks beside that. We will see a bunch of them later on in the course. Classes, like in the CPP file, that's usually where we see the actual code written. We learned about default constructors, other constructors, copy constructors, deconstructors. We learned about all these things. We learned about how toString's kind of important and whatnot. But I threw a lot of information at you, and we haven't even really started 162. In other words, have fun reviewing these slides a lot until you get this. You gotta get this. We're only halfway done the set of slides on reviewing objects. The lab this week is gonna be playing with objects, so you'll have a chance to sink your teeth into it. And assignment 1, it's all about playing with objects. So don't worry, you'll have a lot of time and exposure to these things, but this is going to be critical. This is like, okay, before I can actually teach you anything that 162 is supposed to cover, you gotta know this. FYI. So we've got student objects. I want to make a course class. I want to have like an instance of a course that'll represent like 162. So I'm going to make another class that just keeps track of all the students in the class. It's going to be a really simple one too. A little bit more complex than the student objects. The student objects are, the student class is very simple. It's just holding a couple of attributes to keep track of information about a given student. So now I'm going to make a course one. It's going to be a little bit more complex. Not crazy, but more complex. All this one's going to do is keep track of the students. Keep track of the number of students. And we want to be able to add students to the course, maybe remove students, check if a student's in the course, print out the names of the students in the course, whatever. There's a bunch of things we might want to do. This isn't exhaustive. Maybe what I want to do is figure out like the class average of all the students in the course as well. I don't know. There's a lot of things I could do. Sky's the limit. Remember, we're inventing this. We get to do whatever we want. So which of these will be attributes and which will be behaviors? Okay, think about this for a second. Of the things I just talked about, of these 5, which one do you think will be like attributes, like variables, holding on to information, and which one will be behaviors, like the methods, the functions? Whenever I say method, by the way, it's like a function that belongs to a class. FYI. Let's start with perhaps a more obvious one. Print out the students in the course. Do you think that's an attribute, or do you think it's like a method? A method, right? You actually have to go like do something to print it out. What about adding students to a course? Method. Removing students from the course? Method. How about how many students are currently in the course? A little 50-50. This one could actually go either way. Maybe one way we'll do it is we'll just have the course keep track of how many students there are. So it's like an attribute. It's like number of students in course. And then if someone adds one, I'll update that. Or what I could do is if someone asks, I can go through and count. So it could be a method. It could be an attribute. It could go either way. We'll make it an attribute. What about keep track of the students? This one's tricky. Let me put it this way. What if this was 161 and you were using Python and you had access to lists? Would this be an attribute or a method? Not as confident. That's okay. I'll show you an example of what I mean. I'm throwing a lot of new stuff at you, so don't feel bad. Here is my header for the course. Have a look at this. Take a second, look at it. I realize the font's kind of small. People at the back, can you at least reasonably see it? Yeah, well, there wasn't enough room to squish anymore. But here's the header. I just wrote it all there for you. These are all the things that my class is going to like keep track of and do. My course class. Have a look at it. Do you see anything new in there? Something different, something that stands out? Or does everything check out? Double pointer, yeah, that's kind of weird. I mean, we've seen it before, but that'll be kind of weird. More on that in a moment.
Setting a constant?
Where's the setting? Oh, at the very top.
The default?
Yeah, notice that I'm actually setting a constant in the header. It's not just like a declaration of something. I've actually declared it and actually assigned it a value. There's actually some like actionable code inside of that. That's like running. I set a constant in the header, which is a little interesting, I guess. Yeah, good observation. More on the use of all this stuff as we go, of course. What else do you think? Anything else weird? Pardon? That's the 4 different constructors. The first one's the default. The second one is the not default. The third one is a copy constructor. And the fourth one is going to be the deconstructor. And the copy constructor and the deconstructor that we're going to look at are going to be more interesting. We're actually going to make use of them, and hopefully it'll show you why they're important. Anything else?
You're including the student header?
I'm including the student header. Yes, good observation. I need to include the student header because I'm making use of student objects here. I've got like a student pointer, right? So if I didn't include that, it wouldn't necessarily know that. It would be like, well, what's a student? So because I included it in the header, it's like, oh yeah, okay. He wrote this, I know.
Why is it a pointer?
Why is it a pointer? That's what you were asking about. So why is it a pointer? We'll get there, but I'll explain it right now anyways. I want to have a pointer to an array of students. Okay, so that's one of the stars. It's a student pointer, and it's going to be like an array. Remember how if I wanted a dynamically allocated array of integers, I would say like int star my array equals a new int, and how like that pointer was pointing to the beginning of the dynamically allocated array? That's what one of the stars are. But I just said something that was actually wrong. I said I wanted a pointer to the start of like an array of students. That's not true. What do you think I actually want in my array? Based on what you see here. I'm going to have a pointer to the beginning of an array of what type?
Pointer.
Student pointers. I'm going to have a pointer that points to an array that contains pointers to students. I think I've got an image in there somewhere about it, but I'll just draw it just now just to be super safe. Is that readable? No? Yes? I'll try to make it big. MS is my, here I called it my class. All right, I'll make it MC. There, MC. It's a pointer to the beginning of this array. And the array is not this. It's not little like students in here. That's not it. That's not what we have. That would be like student star my class. But because I have student star star, it actually means I've got a pointer somewhere and there's a student. Maybe there, and so on. That's what I've got. And this is going to become important, especially when we start talking about copying and deleting and whatnot. All right. Any other things about this that you see that's a little fun? Anything at all? There's one last thing I kind of wanted someone to point out. It's okay if you didn't, because I guess it's not that weird. Okay, what are you thinking?
Just like the expand capacity.
What about it?
It's void.
It's void, so it doesn't return anything.
But shouldn't it be like an int if you're just adding like more people?
No, it would, because you don't know what expand capacity is doing, it's reasonable that you're kind of wondering like, what? But the thing about expand capacity that's interesting is it's a method, okay? How do I know it's a method? Well, I have to find the return type, and I got like the parentheses at the end of it. You know it's a method. But unlike all the other methods, where is this one located? Private, which is interesting. That must mean all of these methods I can access from outside the class. But for some reason, I've got this expand capacity method hidden somewhere. More on that in one moment. So yeah. What's up with that? Basically, there's a lot of things in here that's new. But all I did was I've just created the header. So here's what I'm going to do. I'm actually going to copy all this. You can't see me, but it's a double screen. I'm copying all this code. I'm going to go here. I'm going to remember this is the right way to do it. Right click, add, class, course. How embarrassing. So there we've got our course. I've got the course header. And I've got my course CPP. I'm going to go to header. Basically, I'm going to do all this. And I'm all set. Now, for those using Visual Studio, you may have noticed this like pragma once every once in a while. All that means, I'm not going to go to all the details. It's a fancy way of saying, what if I had two classes that imported the same thing? Well, the pragma once is kind of like, well, if there's ever like, just only do it once. That's the quick and dirty explanation. It's magic code. You can leave it there. It's glorious. So there we go. I've got my header. It's all good. But of course, Visual Studio is saying like, well, you declared it, but it doesn't exist yet. Well, yeah, I know. We haven't written the CPP code. We haven't written the actual C++ code yet. All we did is we just defined everything. There's no code there. The most definition so far, I suppose, is the constant. Default capacity of 10, whatever that's for. So, let's think about this class for a moment. I just threw a whole header at you. Don't worry, we're going to go over it. So let's write some code to make the course do its thing. So if I want my course CPP, I'm going to have something like this. I'm going to include course.h so I can have access to basically all the stuff I just defined. And there's nothing in the class because I haven't written it yet. So I'm going to need my constructors, all those methods, assigning things, whatever. So what are we going to start? Start with the constructors. Why not? So here's what we're going to do. We need a constructor that's going to set things up for us. So here's what I want to do. I'm going to use an array to keep track of students, right? If I create a course object and I say, okay, add Bob Smith, add James Hughes, I'm going to store them in an array. And I'm going to keep track where like the next available spot is in the array. Like if there's an empty spot in that array and you give me a new student to add, well, I'll just put it in the next empty spot. And then I'll update, okay, well, where's the next, I need to update the next empty spot and whatnot. That's basically it. I'll just store students in this array sequentially, linearly. Sound good? So in order to get this object started, what are we going to need? Well, I mean, I showed you that header already. Let's have a look. Here's a very simple default constructor. What is it doing? Well, I'm creating, so what's it do? It assigns the one attribute I gave it, num students, to 0. Because when I created a course object, how many students are in it at the beginning? Nothing. There's no one there, so 0, right? Makes sense. Now I'm creating my class. My class was that array. Really, it was a pointer to students. Actually, no, it's a pointer to student pointers. So what do? I make a new student pointer thing. It's a new array, basically, but of course the contents is student pointer, so that's why I need the student star on the right-hand side. Remember, my class was like student star star. But the one star gets us to this array, which is of student pointers. And how big am I making that array? 10. Why was it 10? Because that was what the default capacity was. I could have just as easily made it 100. It doesn't really matter. That default capacity, it's a constant, whatever. I can change it to whatever I want. And by default, we create an array with 10 slots available. Currently, there's nobody in those slots. It's just waiting to put information in. It's empty. There's 0 students in it, but there's currently, array max is going to keep track, well, how many things can I put in this array? Default capacity, it's going to be 10. So currently there's 0 students in my class, but I've got 10 seats for them, basically. Any questions about this logic? Yes?
Is array max just like a variable right now?
Yeah, array max was this. The first thing I defined in the header. I just defined it. I could have made that 100. It doesn't matter. But it does have some sort of value. Any other questions? Yeah?
How come we don't need to state like the types like inside the functions
Because they're already declared.
in the header?
So the types, oh, sorry, you mean the type of the function? You
Well,
don't.
just like inside, like num students. Like
Because it was already defined here.
Oh, okay.
So this is where I say, okay, I've got something called array max and it's an integer. Now the computer goes, that exists. I created it, there's a box in RAM somewhere where I'm going to store this information. It already exists. Now, whenever I use something that exists, I don't need the type anymore.
Okay.
So it's already been created. Good call though. Yeah?
So the line that's like by class, is that just like taking a student and putting it into the array?
Nope, no student has been added to the array.
So what's going on with that?
What it's doing is back in the header, when like the computer was setting all this stuff up, when the header's done running, before I call the constructor hasn't been called. So I start to run the code. The computer knows, okay, an object of this class has all these different things, so it's starting to create this object. This object I'm going to represent as a blob inside memory. I'm going to see if I can find a better marker. That's decent. So here's my blob, and inside it I'm going to create like default capacity, DC. It's got 10 because it was actually already assigned from the header. I'm going to create a little box in there somewhere for like num students. Right? There's nothing in there yet. I mean, there's just garbage in there, whatever happens to be in there. Array max. There's nothing in there other than the garbage that's already there. And my class. MC, and there's nothing in there. It's just empty. But all these things know what their type are, right? I mean, this one knows it's an integer, this one knows it's an integer, this one knows it's an integer. I can only put integers in there. What's the type of this? Well, it's got to be a pointer to student pointers. So great. Now we start running the constructor. Oh, num students get set to 0. Great. I'm going to skip line 2. Array max equals default capacity, which was 10, 10. Now let's go back to line 2. What's going on in line 2? Well, it says, oh, okay. Let's jump to the right-hand side. This is saying, oh, go create a new array of type what? Student star, student pointers. So I'm going to go create a new array that's set up to hold pointers to student objects. So over here, oh, maybe it's over here. I've got my array of size 10. I know it's not 10, but bear with me. I've created it. And you know there's that new, so it's like return the pointer to whatever that is. So we just get the arrow that goes there. That's all we have. No student objects have been created. No additional pointers to student objects have been created. All we have is a pointer to an array that's going to be pointing, that's where the contents will be pointers to student objects.
So the array holds pointers.
Bingo. It doesn't hold students. It holds pointers to students. Big difference. And this will come up when we start talking about copying and deleting the objects. If I give you a second and you think, if I wanted to make a copy of the course, what do I have to like copy over? We'll get there in one moment. All right, great. There we go. Here I'm using an array of pointers to person objects. Should say student objects. I don't know why it says person. I must have changed something. I'm going to take this code and add it to my course. Great. So far, so good. Here's my not default constructor. It's very simple, a little different. It's, well, I know the default capacity was 10, but what if I know I've got a class of like 100 students? Do I want the default capacity, like do I want to create an array of size 10? No, I'm gonna run out of seats real quick. So I'm gonna have the option to create one where I can specify how big that array will be. Does that seem reasonable? This is a great use of a second constructor. So I'm just going to copy this code. Ooh, if I can find my mouse. There. Go back here. What's the difference? The only difference is instead of using default capacity, we just use the parameter size that was passed as a parameter when calling the constructor. That's it. That's it. Yes.
How do you know if you have to make another constructor?
I mean, only if you think that you need it. You're inventing it, right? So in this case, it makes sense. Although we'll see that we don't have to. But really, it's up to you. If you're looking for a hard and fast rule, if and when, you use it, you do it when you need. When do you need? You'll get a feel for it once you get a little bit more and more experience for it. Like with the students, right? I could have created 1,000 different versions of constructors for any possibility that I wanted. Wouldn't really make sense to do that. I can think of a couple of ones that made sense in our context, but really it's just wherever we need it. How do we know? We don't. You get that gut feeling. Sometimes computer science can be more of an art than a science, let's say. Copy constructor and deconstructor, we're going to skip these for a moment because we got to cover some other things. We'll get there. Let's say we want to add someone. So the add function is going to be simple. You're going to pass me all the information I need to create a student object. I will create that student object and then add a pointer to that student object to my class list. That's it. Oh yeah, and then we're going to have to update, well, how many students are in the class? Well, one more, so just like add one. Here's what we've got. Here's our scaffolding. Just okay, void, it's not going to return anything. Course, add, it's going to take a string, a student number, a string, and an average. And all I have to do is this. I'm going to create a pointer to a student object called toAdd, create a new student with the values. I'm just relaying that information on to create a student object. I've got my pointer to it, and then I'm going to add to my class at num students toAdd. Now, let me ask you something here. I'm doing something clever. It might seem, you might scratch your head for a moment, but I'm going to convince you right now that this is brilliant. Let's say I have 0 students in the class. What should num students be? Okay, great. Let's say there's 0 students in the class, and I want to add a student. Which index of the array does that go to? Huh. What if there's 1 student in the class? What's num students? What should it be? 1. Let's say you give me information to add a new student. 1 more student. Which index does that next student go? 1. Let's say there are num students. Just some value, right? Some arbitrary value. I've got num students. And you add a new one, which location does that new student go? Num students. Isn't that handy? Num students ends up actually also being the next available spot. This is a consequence of zero-based indexing, right? If there's no students in there, there's 0 students. Oh, the new one goes into location 0. Just handy, by the way. So if you're thinking, but why how come you're indexing with num students? That's why, because I'm being smart. But as you can see, it's actually not that clever. And after adding that student, what do I have to do? Add 1 to num students. Does this sound good to you? I see some people going, oh, I don't know. Who here likes this? Straightforward, it's simple. Great. Should I be deleting at the end of this method since I have used the new? Oh, remember I was saying that thing about deleting things? For every new I need to delete? Well, that's true, but I don't want to delete this thing. I put it into my array. Well, I put a pointer to it in my array. I want to keep track of it. I only delete the things when I don't need them anymore. It wouldn't make sense to create the new student, add it to the class, and then delete it, and then the class is going to be like, oh, let's go check out that student. Where did it go? You don't want to delete it until you're done. That will be where the deconstructor comes up. Yes?
So with this, you're just indexing it and then you're adding one each time.
Yeah.
Doesn't that create like a problem though with the index is too high? Like it,
Well, what do you mean?
well, like if you keep adding one each time, there's no like index every bounds.
Oh. Who here understands his point? Let's say I use the default constructor. How many seats do I have in this class? 10. What if I have 10 students? I add 10 things. And then I go to add that 11th. Oh, that's interesting. There was a little bit of a hint perhaps earlier. Or are you looking ahead in the slides?
No, it's not that.
Oh. You're just smart, yeah, good job. So the problem with this is we'll run out of seats. Imagine I had 10 seats here. Or like we can look at this first row of students. There's 1, 2, 3, 4, 5, 6 available spots. If it's an array, they're going to want to be in consecutive spots. But there's 1, 2, 3, 4, 5, 6 empty spots. If I had 6 people come up and I say sit in the front row, you're fine. But if I try to add that 7th person, what's that 7th person going to do? Sit somewhere. They're going to try to sit some, but there's no seats left. You said maybe sit on top of somebody. Well, C++ isn't going to be that helpful. We're going to run out of spots. We need a little help. So what are we going to do? Well, how about this special function called expand capacity? Here's what we're going to do. I've got an array that's size 10. It could be anything, but let's say it's 10. And I've got a variable that keeps track of how big my array is. It's max array. If I have an array that's size 10, and I run out of rooms, here's what I'll do. I'll just make a new array that's bigger, copy over the first 10 things from the original one, delete that now, I don't need it anymore, and now I have more spots. So if I ever run out of room, I'll just expand capacity. If I don't, whatever, just ignore expand capacity. I don't need to expand capacity. If I have 10 seats but there's only 3 people in there, just add it. But if I ever run out of room, I got to do something. So here's what we're going to do. Here's how we're going to do it. There's a bajillion ways we can do this, but here's what I'm going to do. I'm going to take my max array and double it. It's a good rule of thumb to say, okay, I ran out of room, well, let's just double it. There's actually a nice mathematical reason we like to double things. That we will learn about a little bit later. But if I had 10 spots and I ran out of room, let's make it 20. And then if I run out of this 20, let's make it 40. If I run out of this 40, make it 80, and so on. Just double every time. More on that later. Then what I'm going to do is create another new pointer to an array of student pointers. But what size is it going to be? Array max, which is twice as big as it was before. Because why? Well, I literally just doubled it in the previous line of code. So create a new one. So let's draw. Inside this class, I'm saying, okay, I'm going to make another new pointer called new class NC. All right? I've created it, and I'm making it point to a new array of student pointers. Wait, no. And its size is twice as big. 1, 2, 3, 1, 2, 3, 4, 5. Whatever, maybe it's not double, just pretend it's double as big. So this is what I've got so far. That's it. Nothing else has happened. And presumably I've got pointers inside of this. If I'm ever having to call expand capacity, this is full. So let's say I have a pointer here to a student, pointer here to a student, pointer here to a student. Right? This is our current state. Here's what I'm going to do. What does this code do? it says, for 0 to num students, go into my class, this is my class, and copy over the contents of my class at location I. What is the contents of my class at location I? A pointer to a student. And copy it into the same index of the new one. Basically, this is what it means. Oh, copy the, oh, okay, so do this. Do this. Do this. Do this. Do this. I know it's getting all smushed, but bear with me. That's what it did. That's it. It goes to num students. No, notice that it doesn't go to array max. It needs to go to, well, how many students do I need to copy over? Well, how many students are there? Num students. So go from 0 to num students and copy over the pointers. Great. Notice I never made a copy of a student, though. No students were copied. I made copies of the pointers. Then I'm going to want to delete what my class is pointing to. But when I delete the thing that my class points to, it doesn't do like a deep delete. It's not going to go, oh, I got to delete this. Oh, but I can't delete this. I got to delete this. C++ isn't smart enough for that. Fortunately, I want to delete just this array of pointers. So that's what that delete means. So I delete this pointer. Well, we go here and we delete this. So that's gone, but notice how the students are left alone. That's what we want. And what last thing do you think I need to do here? I see people going like, yeah, do that. Copy over what's in new class. Well, what's a new class? Oh, well, it's this pointer. Copy over that to here. Okay, great. Great. That's what happened. Isn't this cool? Yeah.
You have to delete new class too.
No, because new class is, so new class, if we deleted what new class, like if we said delete new class, it would delete what new class points to. Where'd you go? There you are. Which would then delete this array. But then my class is going to go, wait a minute. I just pointed to this new array and you just deleted it. That's no good. So we don't want to delete that. But then you might think, but what about that, like the box? What about this box? Right? So I don't want to delete what this is pointing to. What about deleting this box? We don't have to because that's going to be stack memory, which C++ manages for you. Basically, when expand capacity finishes running, this variable deletes itself. It's like, oh, don't need it anymore, it's gone. Yes?
So, deleting my class, that just deletes the variable.
The variables, the box still exists. Delete deletes what it's like pointing to. If you were still scratching your head, here is, I drew it again. Here's my situation. Please be impressed by my beautiful artwork. Those are the student objects. Look how happy they are, except the fourth one there. And the first one's indifferent, I suppose. I create a new array, and I assign new class to it. That's what the code did. I go through the for loop and go boop, 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 boop. There we go. Then I delete that, and then I make a copy of what's a new class, put it there, and that's it. We're done. If I said delete new class, well, that would delete what new class points to. That would be very bad, because we just deleted the new array that we had. Who wants to take a wild guess? Remember in Python we had those lists? We didn't have arrays. Remember how lists magically got bigger whenever you kept adding things to those lists? I wonder if this idea kind of came up there. It's like, oh look, they go on forever. Huh, imagine you were using this class. Imagine you were using this class, the course class, and I never told you that there's an array in here. You don't know that. And you just say, okay, my new course, add a student, add a student. How many students can you add? An infinite. Why? Because if it ever runs out of room, what are we going to do? Well, here was our add before. If I'm just going to keep adding, but then the question you brought up came up. What happens if I run out of room? There's only 10 spots in that array. If the number of students equals that, expand capacity. So let me ask you now. If I kept saying to a student, or pardon me, to a course object, add a student, add a student, add a student, how many can I add? An infinite. Because add will automatically make it bigger. So now, as far as I'm concerned, I don't even need to know that there's an array in there. The whole fact that I might run out of room in an array doesn't matter to me. It matters to you as the original programmer, but if you're using this code and you didn't know, it doesn't matter to you. All right, we'll pick up here on Friday.